sets of X and Y values. Do y'all have the heaters problem?
No.
Yeah.
Yeah.
Oh, I need to forget that.
It's the same problem.
Yeah, it's the same problem. It's giving you two sets of points.
Not true.
Wait, who said it's not true?
I did.
What's not true?
Constant sum.
Read me your problem.
It's a long problem.
Read it to me.
So in high school, years and fixed are going to be modeled by a linear function. T of f of t is that t is a one zero with max at 1, 2 points of reference function. I have 6 and 59 equals 2.
You got 2 points on the graph. It's not the same problem. It's asking you to do the exact same thing. I don't mean it's the same problem verbatim, but I mean it's the same problem math-wise. Okay? You guys, I mean it's just when I say it's the same problem, I don't mean it's the exact same problem. I mean it's the exact same problem functionally. Alright? Because it's giving you two sets of X and Y values. So what you need to do here, number 4, is figure out your X and Y values.
y2 minus y1 over x2 minus y1.
Okay, now on mine, the one Kyle just read, they actually give you the two X and Y values. This one I have to kind of interpret them. 15 heaters for $4,300, 20 heaters for $5,600.
Isn't the money the x?
No. The number of heaters is X, the cost is Y.
Okay. Oh, duh. I see it there. I think there's one equation though that they switched that around.
15 heaters for $4,300 and 20 heaters for $5,600. Okay, so you guys should all have 2 points. This is where you use the slope formula, yes. So my slope is y2 minus y1 over x2 minus x1.
y2 is the highest y value.
Yes, y2 is the highest y value.
So it would be 5,600.
5,600 minus 4,300.
And you have to put the 20 underneath the 5,600 because they have to stay together.
Yes, they stay together. So 20 minus 15.
You don't have to use the higher value for y2.
No, you don't have to as long as you're consistent with them.
Yeah, you'll just be dividing by
I
negative.
usually use the second one for y2 because I wrote it second.
If you don't use the second y2, you'd just be dividing by a negative. So.
Well, either way, you would be.
Yeah, either way, it's going to come out the same. As long as you're consistent with your steps.
This one's asking for the equation, so would that be the answer?
Yes, I'm not done yet. You gotta find the slope before you can find the equation.
Oh, I remember how to do this.
Okay, so my slope is 260. You guys should all use your 2 points to find the slope first. Everybody got their slope? Okay, once you've got your slope, you want to write an equation y equals mx plus b. Okay, now my slope is 260. So I have y equals 260x plus b. And how can I find b here?
The,
Do I remember what to do?
Wait, I thought 260 was
isn't it the y
No,
intercept?
260 is not my answer. I'm not done yet.
260 is your slope. Now you need to plug y and x in to find b.
Okay, I want to plug y and x in, and that will let me solve for b. So I can use either pair for y and x. I don't really have a preference here. You just need to not mix them together. Just use one entire pair. So I want to plug in my 4,300 for y and my 15 for x, and that will let me solve for b.
So don't you multiply first and then divide?
Multiply first, and then I'm going to subtract.
Or subtract, yeah.
260 times 15, 3,900. And I subtract 3,900.
Is it normal to fraction?
problems. If you got a word problem, you should be getting whole numbers.
I'm getting
Oh, I got
decimals.
decimals for sure.
I mean, I got decimals in my
Okay,
point.
decimals?
Yeah.
I got
Okay, decimals are okay, just keep the decimals.
This is mine.
If the problem had decimals in it, then your answer will probably have decimals.
I was given you.
Okay, but either way, once you find your B, you go back and take your equation, put your y and x back in, and then plug in your B, and that equation is your answer. That should be negative 1.47. You got positive divided by negative is a negative.
Right, and then I got the negative right
Yes.
there.
It's gonna change your B.
Right.
Oh, just keep it as a decimal. Use the decimals. Because they have decimals in the problem, you have decimals in your answer. It is.
Does that count?
Figured you should come out with negative, so. Y equals your slope. I want you to write it in the, I want you to, as a thing, to write it in your assumption. You've already got your new equation. Yeah. That's what we're gonna write out. That's a lot of water.
Alright, let's look at number 5. I think that's an average rate of change problem. Okay, for the function y equals x squared, compute the average rate of change between x equals
Mine are
4 and
different
x
numbers.
equals 8. Average rate of change means what? Slope, yes. Average rate of change means slope. So what I need to do here is make an XY table. And I'm going to use that equation to find my y values. Okay, so y equals x squared. So when x is 4, 4 squared is 16. And when x equals 8, 8 squared is 64. Now if you guys have a different equation, you just use your different equation to compute your y values. Okay? Then just use your slope formula. Again, y2 minus y1 over x2 minus x1. Okay, so 64 minus 16 over 8 minus 4 is 48 over 4, which works out to 12 on mine.
This way we know if it's right.
Yeah.
I've done that before. Think it's totally right, then you get it wrong.
Yeah. I like to check. Okay. Number 6. Solve the system of equations by the addition method. You guys may have elimination, addition. Everybody say either addition or elimination.
Number 6?
Yes.
No.
No.
What does it say then?
Does the system below have a unique solution, no solution, or many solutions? What does this mean graphically?
Okay, so no matter what it says, you want to try to solve it first.
Mhm.
Okay? So let's try to solve it. So I've got 3x plus 4y equals 1. And I've got 6x plus 8y equals 0.
Question.
Okay? If I want to solve this by elimination, then I would want to multiply my first equation by, I'm going to turn 3x into negative 6, because I've got 6x. So I need to multiply my first equation by negative 2. You guys are not all going to multiply by negative 2. I'm going to multiply by negative 2 because that makes sense for my problem. Okay, so that gives me negative 6x plus minus 8y equals...
What's going to happen is going to
I want
be
to
0.
multiply 3 by something to turn it into negative 6. So you've got a 4, you want to turn the 2x into negative 4. So you're going to actually multiply by negative 2 also.
In this particular equation, though, it's going to equal 0 equals negative 2, which is... It's not... can't happen, so it's not a solution.
Yeah. So my x and y both cancel? Are you guys confused?
Yeah, I was confused on why you're doing it by a negative, why you're multiplying by a negative 2, but she just told me that that they cancel out.
I want to cancel out 6x with negative 6.
Okay.
So I want to turn the 3 into negative 6.
Gotcha.
Now if I end up with 0 equals negative 2, what does that mean?
There is no solution.
That means no solution. What if you got 0 equals 0? That would be infinitely many. So 0 equals negative 2 is no solution. Now you guys you may get 0 equals whatever, as long as it's not 0. Now what would that mean on a graph if I had no solution?
Parallel line.
Parallel line.
We'll look at that way the result is that. Yeah, let's do that other thing. You know that there's going to be many solutions.
Question, what if it ends up being the exact same solution, but they just cancel each other out? 0?
You have 0 equals 0?
Yeah.
This many
If you have
solutions.
0 equals 0, it's infinitely many solutions.
The way to tell that is the one where it's there is no solution. There's only one question, or there's many solutions. It's actually 2 questions.
Okay.
Because it actually says.
Yeah, it won't be the same questions on the final. So.
Well, yeah.
That's
It'll be
true.
questions you guys haven't seen before.
But the way to solve them is the same.
They're the same questions, yes. It's just not these exact questions. The procedures are the same.
So when there's infinitely many, does it mean that the 2 lines are the same?
Yes.
Should put all these in the notes so you can find them.
Okay, it's actually 12:15, so why don't we take a break at 12:30 and then we'll pick back up again.